Objective, exponential situations. Number 1, the pesticide DDT was widely used until it was banned because it is toxic to a wide range of animals in aquatic life and is suspected to cause cancer. DDT takes a long time to disintegrate after it is sprayed. The chart below shows the amount of 100 grams of DDT remaining in the environment after a certain number of years. So notice it gives the number of years of spraying and the grams of DDT remaining. The first thing that it asks us to do is to make a scatter plot for the given data and sketch your results below. All right, so I'm going to get started on the scatter plot, and then I'm going to show us what we can do to just speed up the process a little bit. For sure, the first top row will be our x and the bottom row will be our y. So x is the number of years, so let's make sure that we label this. And then y is the grams of DDT, grams of DDT. And especially because we don't have a lot of space, we're not going to worry about being real accurate. And actually, I'm going to allow us on this one to use the Desmos on our computer, so that's exactly what we're going to do right now. All right, so we're in Desmos right now, and what we are going to do, if you recall, we are going to hit the plus sign to give us a table. So I'm going to go to table and just plug in the values 150, 224.8, 312.5, 4, 6, 5, 3.125, and then we'll get a 6, 1.57. And then what we're going to do from here, just to make sure that we can see all of the values, remember we're going to go over to the wrench, and I'm going to click on write this number by the x-axis. My smallest x is 1, so I'm going to start my smallest x at 0. And my largest x is 6, so I'll go out to 10. And then go to the y-axis. The smallest x I see is, make sure you're looking at it, it's actually the bottom one, 1.5, so I'm going to make this go to 1. And then the largest x I see is 50, so I think I'll go to like 55. Right, and then just click anywhere off the screen, and then you can notice, I'm actually wanting to change that color. Oop, no, I guess I'm not going to change the color. All right, so that's what I get, and if you look, you can definitely see that exponential curve. So now, back on our paper, we can draw those dots just in the form of that exponential curve, that it's starting up at 50, and then it's heading down. So, let's go back to our paper now. Now we are back on our screen, and we are going to go ahead, I'm going to just make sure that that's up at about 50, and then we know we go over to about 6, and then we know we start up at 50, 2, 3, 4, 5, 6. There are 6 dots, and that's somewhat what the curve looked like. So that would be a nice scatter plot of our function. Right, this next one says to write an exponential function. Since this is definitely exponential, we know we're going to write y equals a times b to the x. Keep in mind that our b is our growth rate, and to find our growth rate when we're given a table, remember we're going to backwards divide, so that's what I'm going to do for each of these numbers. And if you have your calculator, you definitely should have done this yourself, or take a minute and do that so you remember it for the test. 1.57 divided by 3.125, if I round it to the nearest tenth, is 0.5. 3.125 divided by 6, rounded to the nearest tenth, is 0.5. 6 divided by 12.5, rounded to the nearest tenth, is 0.5. 12.5 divided by 24.8, rounded to the nearest tenth, is 0.5. 24.8 divided by 50, rounded to the nearest tenth, is once again 0.5. So you can see from this chart that our growth rate is going to be 0.5. So it's going to be y equals something times 0.5 raised to the x power. Make sure you put the x up in the exponent spot. And then a, remember, is our starting amount, and that's what's happening at 0. So you'll notice this chart does not start at 0, so I'm going to put a 0 on the chart, which means I'm going to have to backwards divide one more time to get to it. So we're going to do 50 divided by 0.5, and we get 100. So 100 is our starting amount. And actually, if you read the problem, it did tell us that we started at 100. So I guess that's kind of a cheating way to do it. All right, now it says to use your model to determine how many grams of DDT will remain 120 years after it's sprayed. So the workout I'm going to show is 100 times 0.5 raised to the 120 power. Okay, when you do that, when you're using your calculator, your calculator should say 7.5 with quite a few decimals times 10 to the negative 35. and then I'm going to put grams next to that. And if you think about this, really what this means is I'd have to move my decimal 35 places to the left, which means it's going to be really, really, really small. So we could say about 0 grams of DDT will be left. So it's pretty much going to be out of the environment by that point in time. Okay, problem 2. There are a total of 128 teams at the start of a citywide 3-on-3 basketball tournament. Half of the teams are eliminated after each round. Part A, write an exponential function to model the situation. So if it's exponential, we're going to have y equals a times b to the x. So I'm going to have y equals, how many teams are we starting with? 128 times b, which is the growth rate. Half of the teams are being eliminated, so we're only going to be left with half, and then to the x. And if you would prefer, you could rewrite this as 128 times 0.5 to the x. It doesn't matter, you can take your pick. All right, part B, it says how many teams will be left in the tournament after 5 rounds. So our answer, we're going to do 128 times 0.5 raised to the 5th power. So 128 times 0.5 raised to the 5th power is 4 teams. There will only be 4 teams left after 5 rounds. Okay, and part 3, a recent college graduate accepts a job at a law firm. The job has a salary of $32,000 per year. The law firm guarantees an annual pay increase of 3% of the employee's salary. I'm going to just circle the word increase, and I'm going to go ahead and change 3% to a decimal, which would be 0.03. Right, it says to write an exponential function to model the situation. We know that we'll have y equals a times b to the x. So we'll have y equals, a is the starting amount. Well, it says that the starting salary is $32,000, so 32,000 times b. Since we are increasing, we are going to add 1 to it, so it's going to be 1 plus 0.03, and since it's exponential, it has to be raised to the x power. And then I'm going to just rewrite this one more step, 32,000 times 1.03 raised to the x, because 1 plus 0.03 is 1.03. Okay, part B, what will be the employee's salary after 6 years? So we're going to do 32,000 times 1.03 raised to the 6th power. And if I raise that to the 6th power on my calculator, and I want to know how much this is worth, it's going to be $38,209, and if we round it to the nearest cent, it'll be $67. Or if we wanted to round it to the nearest dollar, it would be $38,210. Either one of those would be correct.